Hello. I know I said I would wait with a response, but I had some time and somehow I enjoy making these videos, and I had an urge to address some of your points in detail. The first thing I want to address is your objection about my perspective video, where you claimed it wouldn't work this way. The streetlights would be elevated out of the ground, and there is no vantage point, but everything vanishes to the horizon line, even when this wasn't subject of a conversation so far. This was maybe the most revealing indicator for me that your motivation might not be understanding, but disagreeing out of principle. Of course, the streetlights are not elevated out of the ground. The same rules of perspective also apply for the ground, which rises together with the foots of the street lamps. The vanishing point is dependent from the viewing direction and has nothing to do with the horizon line. We can also look upwards in a forest and see how trees which grow parallel in the same direction seem to grow towards the vanishing point. Let's talk about your objection that the telescope isn't aligned parallel with Earth's axis, but in a triangle. For this, I want to show what happens to the angles in a triangle with an extreme long side. But I don't want to use Earth's radius for this. I want to go a lot bigger and take Earth's orbit around Sun. The diameter of the orbit is about 186 million miles, or twice the distance between Earth and Sun. Polaris is about 430 light years away. That's about 2.5 quintillion miles. This is a 25 with 14 zeros in miles. We also know Earth's tilt is 23.3 degrees. In addition to the 90 degrees to the ecliptic of Earth's orbit, we get an angle of 113.3 degrees. With two sides and one angle, we have everything we need to calculate the triangle. The only problem we have is to find a calculator which is able to deal with such large numbers. But when we divide the 2.5 quintillion miles by the 186 million miles, we get that the distance to Polaris is 13.5 million times bigger than the diameter of Earth's orbit, which is impossible to draw here in scale, but having the relation enables us to enter it in an online triangle calculator. I used the values of 1,000th of Earth's orbit and 13,500 for the distance to Polaris, and got 0 degree at Polaris and 66.7 degree at the other end of Earth's orbit. And it confirms the fact that the sum of the inner angles of a triangle always is 180 degrees. If we would draw it in scale, it wouldn't look like a triangle anymore, but like a straight line. And when we look at the angles from Earth's orbit, we see the sides of the triangle going that much in the same direction to claim they are parallel, with a too small deviation to even calculate it in any normal calculator or to measure even with precise instruments. And this is only about Polaris, not about the celestial pole which doesn't go 430 light years away, but straight to infinity. Back to Earth and looking through the telescope again. We align it parallel to the rotation axis at the celestial pole, and since we learned that even the diameter of Earth's orbit has no impact on its position, we know the Earth's radius, mountains, and the height of the tripod the telescope is mounted on is absolutely negligible for the angle we have to align. The only thing having an influence is the angle of the ground towards the sky. For better understanding, let's say that it stands somewhere in North America at night time and we are facing the Atlantic Ocean right now, and it is northern summer. Half a year later, Earth is at the other side of the Sun, and because the rotation axis remained in the same orientation, we have northern winter. And for the telescope in North America being at the night side here, Earth's rotation is 180 degrees further around Earth's rotation axis, and we are facing the Pacific Ocean in this picture. To spot the celestial pole, we have to align the telescope in the exact same angle. It is the exact same direction. The pole doesn't change its orientation, not within the 24 hours of Earth's rotation and not within the 365 days of Earth's orbit. Of course, when we align our telescope not to the celestial pole, but somewhere else, this would be a different spot. When we position our telescope on a different latitude, the alignment can't be the same, but for the same position aligned to the celestial pole, there is no change. For the polar star, on the other hand, which is not exactly at the celestial pole, but rotating around it like a lot of stars, only at a distance to it which isn't noticeable to the naked eye, half a year later, at the same night time, it's rotating at the opposite side of the celestial pole, like all other stars, and still at the same distance to it, which is noticeable to the naked eye, which is perfectly consistent for being at the opposite side of Earth's orbit around the Sun. But now let's leave consistency behind. What if it weren't for the diameter of Earth's orbit, and the polar star would be much closer but somewhere on Earth's rotation axis, and it would stay there? What if we wouldn't align our telescope parallel to this axis, but to a much smaller and much more defined triangle? It still wouldn't be at two different places half a year apart. The alignment would be still the same, even when the night switched to the opposite side, as long as Earth's rotation axis keeps its orientation. So your objection doesn't even make sense if we couldn't assume parallelity. It would be quite similar to a flat Earth, and I don't want to talk about how different the movements of the stars would look like from any place here, or how impossible it is for the Sun to not set for the whole world at once, or the countless other contradictions in physics and geometry, which are so obvious that it's hard to believe someone could ignore it. But obviously people can. But also for a flat Earth, we would need an axis of rotation. And regardless of which is rotating, the flat Earth or the sky, Polaris would have to be on the rotation axis, and the rotation axis would have to go through the North Pole. And then the fact alone that Polaris doesn't move is not an indicator for the shape of Earth. But the position of Polaris dependent of the position on Earth's surface is, like I said before, with Polaris that far away and the telescope aligned parallel to the pole, it doesn't matter how long the tripod of the telescope, the mountain the tripod stands on, the radius of Earth, or even the diameter of Earth's orbit is. Only the angle of the ground towards the sky has an influence on it. And it does change exactly like we move on a globe with a diameter of 69 miles for each degree the position of the stars change, multiplied with 360 degrees, which is a diameter of about 25,000 miles. But let's look at the flat Earth example again, with a much closer polar star. You told me that we couldn't triangulate here because we don't have the same elevation everywhere on Earth's surface. But that's not a hindrance, because we have altimeters and we know distances between points on Earth's surface. So we have at least something to calculate with. The question is, can we somehow make the position of the polar star, which is consistent with the globe Earth, and such a huge distance to it, which makes any surface elevation negligible, can we also make the position consistent with a flat Earth, with a polar star close enough that we have to take surface elevation into account, with the distance to the geographical pole, where the polar star is 90 degrees upwards, and the angle to the polar star from the own position? We have one side and two angles of a triangle, which is sufficient to calculate the rest. So I start at my position near Munich, which is at 48 degree latitude, which is the same angle I have to align my telescope to see the polar star. North Pole is 2,898 miles away, so I enter 48 degree, 90 degree, and 2,898 in a triangle calculator, and get 3,218.56 miles for the distance of Polaris over the North Pole. But I have to add the elevation of my location, which is 0.3 miles above sea level. So Polaris should also be 3,218.86 miles above sea level. I think we can round up to 3,219 miles. I wonder why no flat earther has done this calculation so far. It's pretty easy. Let's try another location. I want to make a trip to Ibiza. Hey, they know how to make parties there. This island is at 39 degrees latitude and 3,590 miles away from the North Pole. I enter 39 degrees, 90 degrees, and 3,519 miles in the calculator and get 2,849.63 miles for the distance of Polaris to Earth. That's about 369 miles lower than in the calculation before. So if we make some adjustments in the altitude of the surface, we have to say that Ibiza has to be 369 miles above sea level for this to make sense. And I'm pretty sure that the highest mountains are about 5 miles above sea level and not located in Ibiza. I think now I know why no flat earther has done these calculations. But you see, it isn't hard to calculate. There are tons of online triangle calculators, and for adding or subtracting the height, you don't even need a calculator. I suggest you try this for your location and then compare it to Ecuador. You would be surprised how inconsistent this is. To be honest, I'm not sure if this video does help for better understanding. You showed your ability of doing geometry, but you still have doubts about Earth's shape. It doesn't make any sense to me, at least not from a logical standpoint. I don't know if you still want to show me any of the devices and experiments you mentioned, or if you even want to continue our conversation. I would be glad, but I fear that we both have standpoints we are not able to let go, and there is a conflict between the information we want to submit and the things we are ready to accept as truth. Of course, this fears results from countless discussions with globe deniers before you, and I would be happy if you proved me wrong, at least in this point. However, take care and have a good time. Bye.